Find the domain of r of x equals x squared minus 1 over the square root of x minus 4. Now, we need two things to be true here. We need the denominator to not be equal to 0, and we need the radicand to be greater than or equal to 0. I'm going to start by looking at the radicand here. We know the radicand must be greater than or equal to 0, and that means that x minus 4 must be greater than or equal to 0. To get x alone, we can add 4 to both sides of this inequality, and that tells us that x has to be greater than or equal to 4. But we also have to make sure that the denominator is not equal to 0. Now the denominator is the square root of x minus 4. So we have the square root of x minus 4 cannot equal 0. Oops, cannot equal. All right. So to solve this, if we have an equation, and even though this is an inequality, it's a not equals, it's fine here. If we have an equation and we need to solve for a variable inside a radical, inside a square root, we can get rid of that square root by squaring both sides of the equation. When we do that, we end up with x minus 4 is not equal to 0. And then to get x alone, we add 4 to both sides, giving us x cannot equal 4. The reason we have this restriction is because if x was 4, then we would have 4 minus 4, which is 0, and the square root of 0 is 0, so we would have a 0 in the denominator. So we have these two restrictions. X has to be greater than or equal to 4, but also x cannot be equal to 4. If we look at what numbers satisfy both of these restrictions, those are going to be the numbers that are just greater than 4. For example, if we were to take this first restriction and we were to graph the interval on the number line, 0, 2, 4, 6, 8, this would be a closed circle on 4, and then we would shade to the right. If we only had to worry about this first part, this would be our domain. However, we know that x is not allowed to be equal to 4, so what that means is that we have to throw out 4 as a solution. 4 is no longer allowed to be the solution, to be a solution. And when we want to represent that a number is not a solution, we have to use an open circle there. And so if we rewrite this with an open circle, that gives us our restriction, x is strictly greater than 4. So the domain here is going to be the set of numbers x, such that x is strictly greater than 4. This was more challenging than the others because we had to worry about both of the restrictions, that the radicand is greater than or equal to 0 and the denominator is not equal to 0. Most of the problems we work with won't involve both of these restrictions, but we want to make sure that we can deal with scenarios where we encounter them both at the same time.